Okay, welcome back. Welcome back in groups, I should say. It looks like there's a few people that still aren't in groups, as far as we can tell. So, if you have a group but haven't submitted the form to say that you are in a group, please just do that. We're gonna assign people randomly, probably today or tomorrow. So please take care of that. So, okay, Piazza. I think there's been a little bit of confusion with Piazza. So, if you're not signed up on Piazza because you went there and you're like, oh, this class isn't added for me already, you've got to click through a couple times to add a class and then do a search for CSE 469, and then it'll come up and you can add it. So if you're not on Piazza, that's kind of a critical step to us communicating well, right? We talked about this, that we've got to communicate in some alternative manners because of my employment situation, right? So please sign up for Piazza. That's where all critical announcements will be posted. You'll get an email. If you don't like getting one-off emails, you'll get digests, but please sign up. Okay. For those of you that are signed up on Piazza, I hope you saw the announcement that I changed the midterm. Hopefully it's still far enough in advance that it's not going to cause any problems. If it does cause problems, please let me know, or the TAs. They're really nice too. So, and we'll work something out or we won't. No, I'm just kidding. There are certain circumstances that working something out is allowed by the university. So if it falls under that, then we'll work it out. Any questions about the midterm? So really, it's just moved up one class day. Well, what that does is it makes it so it's no longer the week before spring break. Both of my TAs are not here the week before spring break. So I need their help. So we're going to change. Plus, I had to change a couple other things too. So, okay. Any questions? All right, then let's do a little review from last time. Who conducts public investigations?
Public agency, like the police or like the FBI.
A public agency?
Like a government.
Government agency, yes. Very good. So what does that mean about private investigations? Who conducts private investigations?
Corporations.
Yep, corporations, the people that are actually interested in the investigation. Okay, what is the first step in the criminal legal process? Yeah. What? No, criminal process, yeah. A complaint is filed, right? Someone broke into my house, I call the cops, that's the complaint. Okay, something like that. Very good. So unless the authorities know that a crime was committed, there's no way they can start an investigation. Okay, there are 3 levels of law enforcement expertise. What are they? 1, 2, and 3. Very good. No, just go ahead.
Street officer, detective, and digital.
Okay, what is a street officer? What are they able to do? What is their technical expertise? Yes, so you said they acquire and seize evidence. So I'll have to go back and double check the wording on that. But so acquire, I want to make sure we have a good understanding of what we mean in that context. So a police officer, random street police officer, is not going to do the forensic acquisition, meaning making a copy of the digital evidence, unless it's something like they have a cell phone and they have a cell phone cloner that's with them, like in the back of their car. Usually acquiring, it has a couple of different contexts, like seizing it can also be called acquiring, but for the purposes of this class, acquiring pretty much always is going to refer to the forensic acquisition. So that wasn't a fault of your part at all. I just want to make sure that was clear in case you see the term acquisition used in that context. Okay. All right. What's the second level of What? What? What are you saying? Did I have it wrong?
No. I mean, that's what I put too.
Yeah. So, yes, it's not wrong. I just want to make sure you understand what kind of acquisition I'm referring to. Okay. All right. What's the second level? Yeah.
Like detective level.
Okay. What can they do? What's their level of expertise? What are they capable of doing?
They kind of like manage the high tech investigation. I guess kind of like taking the evidence that like is getting into it more.
Yeah.
I think they know what, like, they kind of have an idea of what is and is not like possible to do
Mhm.
with
Yes.
like the technology.
Exactly. Yeah. Hand over here.
I was going to say the same thing.
Okay. Perfect. Okay. What's the third level? Yes.
Forensics expert, digital thing.
All right. What can they do? Yeah, exactly. So the other two, they at least have a good, solid understanding of the process, right? But these forensic experts, they're the ones with the deep technical knowledge, and it might be in a very specific area. And there's other people in their forensic shop that have complementary skill sets. So that if they don't know something, another person on their team knows how to do it. Okay. Very good. So what's the big difference about how private investigations are conducted versus public investigations?
Public investigations need to follow the law. So they have to maintain like chain of custody, and there's a very strict, documented process for how the investigation should be handled.
Yes, that's true. What else? There's more. Yeah.
Private investigations kind of follow, since they're hired by a company or an organization, they need to follow the organization process or
Mhm.
the company laws rather than, I mean, obviously they need to do things that are legal, but rather than the legal process.
Yes. Yeah. Exactly. So does that mean that? So does the company have to follow the Fourth Amendment?
Oh,
What do you think?
I think the company does still have to follow the Fourth Amendment, because then if it comes to escalating that to a criminal, from a civil case to a criminal case, it would not hold up if they didn't follow the Fourth Amendment in the first place.
So close. Yeah.
Is it like if they sign a waiver and they're like, say their phone is company policy, then they don't because it's company's, so it's not actually theirs?
Okay. Now you're touching on it. So what does the Fourth Amendment say? It says that we as citizens are secure in our possessions, right? Not someone else's possessions that they gave to us to use for work, right? You see the difference there? So if it's company property, they don't have to have a warrant. They don't have to have, it's theirs. They will take it and they will start their investigation. Very good. There's one more thing that I had in mind that is different about how public versus private investigation is conducted. And this is how, if you are going to go in and help a company do a forensic investigation, what do you have to be careful of? That you don't have to be careful of in a public.
Disrupt their things. I mean, we don't know business.
Yes. Very good. So in a private investigation, you have to make sure to not disrupt the day-to-day business operations because I mean, it could be, well, number one, you're not law enforcement, so you don't have the jurisdiction to go in there and disrupt their day-to-day operations, which means if you do disrupt them and there's financial loss, you are liable, right? So kind of a big deal. Okay, very good. What are the 4 rules of evidence? Yeah. Authenticity, admissibility, completeness, and accuracy. What does accuracy refer to?
Reliability of the process.
Yes, not the data itself, but whatever created it. Very good. And that's where you have to have that deep technical understanding to be able to explain to a judge or a jury why this evidence is trustworthy. Very good. What is a chain of custody form? What do you use it for? What goes on it? Yeah.
To track when evidence is checked out from where it's being kept, so you know who has it at any given time.
Yeah, it's very good. Why? What's such a big deal about that? Yeah.
It proves the integrity of the data that wasn't tampered with or messed with.
Yes. Yes, but if it does get tampered with, what does the chain of custody do for you? Tells you who's responsible, right? Whose butt's on the line if things get messed up, right? Very good. Okay. What are the steps in the forensic process? Yeah.
Acquisition.
Yep.
Authentication,
Yep.
analysis, reporting.
Yes. So how do you remember them?
AAA.
AAA. Oh yeah, and then there's a report, right? Okay, very good. All right. Any questions from last time as you've kind of had that material simmer in your subconscious the last 2 days? All right. I'm excited. Okay, so would you? Wow. Let's do this. Okay. So the next thing we're going to do is I'm going to introduce to you the group project. Okay, we're going to go over it. This might be a mistake because anytime you like announce an assignment, students like stop paying attention to the lecture, right? Because they're thinking about the assignment and they're worrying about it and everything, right? But I want to make sure that I present this to you. So, provide a little context. I worked 15 hours yesterday for the Army because we had to go down to Fort Huachuca and back with like 10 hours of meetings, right? So I am a little sleep deprived, and I didn't have as much time to complete this project description as I was hoping I would. So there are some holes, but most of the technical information is there. I will fill in probably this weekend, but you can find this on the course website by going to assignments and then group project report and clicking on that. So you see that it's due on April 25th, but we have a checkpoint. Okay, so we want you to have some basic functionality ready by March 28th to make sure that you're not in too much trouble, okay? So let's talk about this. So what we're going to do, what I'm having you do is create a blockchain that keeps track of the chain of custody, okay? So now that you know what a chain of custody is, that's why I'm announcing the group project to you now, because you understand what it is, what's important about it. So if the government wasn't shut down, this link, this right here would work, but when you go there, it says, due to a lapse in federal funding, we can't show you this page. So awesome, right? Yeah. But luckily Google caches things for us, so we can actually, this is kind of just a reference chain of custody form, and it might be beneficial to you to refer to this, or if you, there's some sample chain of custody forms in the textbook if you purchase that. So this is the kind of information that we're trying to duplicate digitally with this project, okay? So take a look at that a little more closely in your spare time, since you have so much of it. No. All right, so we have the things that we're trying to capture in a chain of custody form are where the evidence was stored. Sorry, is that too small? Let me zoom in a little bit. All right, where the evidence was stored, who had access to the evidence, when, what actions were done to the evidence, all of that, okay? So what you're gonna be doing is writing a program that'll be a digital equivalent to a chain of custody form. So I talk a little bit about how blockchains were supposed to change the world, but they didn't. And here's this really cool decision tree diagram that helps you know whether or not you might have a good use case for a blockchain, right? And I throw this in here because, this is kind of an academic exercise in blockchains. This is not supposed to be production ready for a forensic shop to use, okay? And one of the things that I'm going to have you do in the report for this project is explain why it's not a good fit, okay? And hopefully after creating a blockchain, you will be able to spit that out really easily. Okay, so this is how I'm going to give the specifications for all of your programming assignments, okay? And the reason why is because this is how programs are documented, right? So you should be able to, that's a really important skill as a programmer, is to be able to read documentation and understand what how to use programs by reading the documentation, the usage, right? So these are the functions that you need to be able to, that you will implement in your chain of custody blockchain. Add, check out, check in, log, remove an item, and then init and verify. Now these are actually the two functions that you're required to have implemented by the checkpoint, okay? So some very basic rudimentary functions. You're not adding anything to the blockchain, but you've at least defined some of the binary structures. So let's talk about these functions really quickly. You're going to add a new evidence item to the blockchain. Then it's going to have a state of checked in. When you check something out, you've got to say, let's see. Yeah, you're going to say what item was actually checked out or checked in. So log is basically just a view function. So it's going to go through the blockchain, and for the item that you give it, it will display all the blockchain entries for that evidence item. Okay, so that's if you're going to like write a report or dump it into a PDF to use as an actual blockchain. This is how you would get that information out of it. Now, I hope that a lot of you have used Git, right? So I'm going for similar functionality in Git, right? Because, well, Git is kind of a blockchain if you think about it, right? You've got a hash function that it has a parent hash and it's decentralized and everything, but nobody's ever called it a blockchain. I wonder why. You ever heard Git referred to as a blockchain? Sorry, random thought. Okay, so the log is basically like Git log, right? So what actions have happened in the history? Remove, this is, the reason why this is there is because on a chain of custody form, there's a place for you to fill in when the evidence item was either discarded, destroyed, or returned to the owner. So that's providing that information. Init is really just a sanity check. That's all it does is start up your program, check for the initial block in the chain, and exit. Okay, and then verify is where it goes through all the blocks in the chain to just make sure that there aren't any issues with parent and child hashes. Okay, all right, and then you can specify case ID, item ID, reverse the log when you look at it, and change the number of entries, give a reason why something happened, and if you release it back to the owner, you have to say who the owner is, blah, blah. Okay, so this is where I was literally editing this right before this class, like frantically, like I gotta get this up on the website because I'm gonna talk about it today. Okay, so this just describes the binary structure of each block, okay? This, as I kind of go through and make sure that the description is consistent, this might change a little bit, but not very much. Okay, so hopefully all this is intuitive or at least easy to understand. Your initial block should have these values. If your system can't find the block, and then you need to, it has to be in binary format. So I'm going to mandate that. You can't do JSON, you can't do CSV or anything like that. It's got to be binary because I want you working with bits, because that's an important part of forensics, okay, is understanding how data is stored. Apparently I'm still on Slack. Hold on a second. Just go like that. Okay. Now, I'm going to require you to write a report. You'll notice that the report requirements for this are very similar to the report requirements for your paper report. So I'm not going for killing you off by making you write lots of nonsense, okay? I want you to give me information about what you learned about this project from doing this project. Some of the challenges that you faced, the things that you learned as far as like blockchain and forensics, anything, right? So, and like I said earlier, I want you to give a discussion on why blockchain is not an appropriate choice for chain of custody solution. Screenshots are good, but they don't count towards your 5 pages, so they got to go in appendix. Okay. All right. Checkpoint, like I said before, due March 28th. And init and a verify need to be implemented. Submission details, we don't have the homework submission server up and running yet. So that's why there are no submission details. That's another piece of this description that will come later. But basically, you're going to submit your project the same way that you submit all other homework. So by the time you're ready to submit your project, you will have done it a few times. Questions? Yeah.
So the program we do in groups, and then I'm assuming they're
No, group.
Okay.
Yep. Yeah. Yes.
Is there a reason why we're not using like the school's Blackboard or Canvas systems for some?
Yes, I hate them. Actually, I have no experience with Canvas, so I can't say that I dislike it because I don't have an opinion one way or the other. But this automatic grading system, if any of you have taken Dr. Dupay's classes, same system, okay? We just got to get it up and running. So the benefit of that is that we can automatically grade your homework with this system. So we can test it and see if it's passing all the tests, which tells us if you implemented all the functionality that we required you to do, which I doubt Canvas has built into it. So, unless it does. Okay. All right. Any other questions?
Assuming you're in Python, the programming language doesn't matter if you use 2 or 3.
Oh, you didn't just say that. Oh. Okay. You want to go on that tangent, we'll go on that tangent. We're going to talk about Python in a minute anyway. So there's one good reason to use Python 2 anymore. And that's because Pwn Tools hasn't ported over yet. That's the only library, that's the only reason why you should use Python 2, okay? Python 2 is end of life next year. So if you write any code in Python that is gonna live longer than a year, don't use Python 2, okay? Python 3 has some amazing functionality, some amazing features. I mean, I'm talking named tuples and the star parameter and F strings. There's so many awesome features in Python 3 that you would be handicapping yourself by using Python 2. Plus introducing security vulnerabilities in a year when it's no longer maintained. What's that? What? No way. Who? What's the name?
It's because they're using resources from Berkeley. Yeah, and that's from like a long time ago.
Okay. Just gonna move on. I'm sorry that you're being forced to use Python 2. that makes me sad on the inside. Okay, any other questions? Yeah.
Yeah, do you have any your guideline or tips to stay on course, I guess?
No, nothing more than just you gotta come up with your own timeline, right? So I'm not gonna force you to submit a Gantt chart of your schedule and stuff like that. Like, this is not software engineering. This is not a software engineering course. Hopefully you've learned how to do that previously. And I mean, I'm not saying you have to use a Gantt chart, but having some kind of idea of, okay, we're gonna get to this milestone by about this time is really good for project management stuff. So I realize I didn't answer your question fully because you distracted me with the Python 2 thing. I don't care what language you do this in, all right? And I apologize that I wasn't able to paste stuff in here, but like I said, a long day yesterday. As long as your code is Unix compatible and will run in Ubuntu 16.04, Sokwa, is that correct? 16.04. That's all that matters. So you will be required to submit a makefile along with your program. If you've never created a makefile before, I will provide details, some instructions. So that is more information to come. All right. Does that make your life better?
Yeah.
Great. Okay. Yeah.
So we will have other programming plans.
Oh, yes. Oh, yeah. Yeah, I'm excited for some of them. I think we have one programming assignment that will be group-based, and then one group-based assignment that is not, that Adam has come up with. It's all about phishing forensics, which is awesome. I'm really excited for him to give that lecture. What was the question you just asked? Me neither. Oh, but a few more individual programming assignments. And really, these assignments that I'm going to give you are they're not crazy difficult in terms of programming. What they do is they force you to figure out, number one, how to read the specification. So this stuff, like if you can break this apart for each of the programming assignments and really understand what they mean, the programming part is actually not very difficult. And that's on purpose, right? I don't want you spending forever on the programming part. I want you to spend however much time you need on the understanding the forensics part. So that's why I designed them that way. Yes?
The paper is individual.
No. Paper is group.
So you can have to turn one over for a team.
Yes, one report for each team, just like there's just one code set for. Any other questions? This is the other reason why I didn't save it for the end, so you could ask as many questions as you needed. Okay. All right. Yes, go ahead.
Yeah, so is this project, like, you're gonna tell us about it now, and then we're just gonna like figure it out and work on it, and then submit our checkpoint at like the checkpoint time, and then from there we'll continue figuring out, and then submit the final thing on April?
Yes.
And you're not gonna like talk about this again, basically, I mean, for the most part?
I mean, I'll talk about it as we get close to the checkpoint. I'll bring it up in my daily announcements, but I'm not gonna force you to come and talk to me during office hours or anything like that. Okay, we're good? Okay, so again, the idea of me introducing this to you now is just to kind of for you to start wrapping your head around what this means, how you and your partner might go about programming it, that kind of thing. And I'll get you some more details to fill in the holes. And I apologize. Who's ready for some Python? Huh? Yeah? Okay. So this is a presentation that I created several years ago for Dr. On when he was teaching this course. He asked me to write up a project description, which actually for this course, I broke it apart into 3 different homework assignments and came up with a new project. And I designed this presentation specifically to introduce you to elements of the Python language that make the programming assignments easier. So that's another reason why I'm introducing this today, is because now that I've given you the project description, hopefully with this in mind, you'll see, oh, hey, you know what? I don't know Python, but this presentation has a lot of the stuff that I need, explains how to do pretty much everything that I need to know about Python to do the programming assignment, or the project. So that's my purpose. I've had to update it a couple times, but hopefully for those of you that don't know Python, gives you at least a little understanding, a little taste for the language. Okay, we're going to talk about a few things to just introduce the language to you if you've never seen it before. The first one is that Python is an interpreted language, meaning if you've come from C, C++ world, there's no compiling the code. There's no that you have to do. It's kind of similar to Java in that there's something that happens to the code right before it runs on the processor, because obviously the code that you write isn't ready for the processor. So, but what's really great about Python is it has this interpreter that is an interactive interpreter, that allows you to type in snippets of Python code, see the output, and see what you did in Python. That was something that drove me crazy about C++. That was the first language I learned, and when I was a CS major, was that it took there was like this whole process to figure out if I'd even done anything correctly, because I had to compile it. And with the interpreter, you can just type your code right there and see the results without having to go through this extra loop of stuff. Okay, so 2 things that are really important to know how to use when you're getting started with Python is dir and help. So dir is a function that you can call on any object in Python, and it'll tell you the properties and the methods that are part of that object. Okay, I use this a lot when I'm like, oh man, I know there's this method for ints, but I don't remember the exact name of it. And so I open up interpreter and I run dir on an int, and there's all the function names. Okay, the other one is help. So everything in Python is documented pretty well. And this running help on any object will bring up the documentation for that object and paste it right into the command line, the screen, whatever. My brain juice is running low, so you're gonna have to bear with me today. Okay, so those are some really high-level intro stuff. Variables in Python, all variables are dynamically typed. Everything is an object. It has callable functions, and dir is how you list them. Strings, there's 3 ways to specify a string: single quotes, double quotes, and triple double quotes, so internally, all of these are the same. There's no difference between one or the other, so using one or the other doesn't produce a different data type. Okay. The only difference is that with the triple double quotes, you can do a new line, and it'll insert the new line character for you into the string. Okay. Also, there's a bunch of string formatting information at the documentation here. As of Python 3.6, you can do something really cool called f-strings. I'll introduce those in a second. Okay, lists and tuples. There's 2 types of arrays in Python. First are lists. They can be changed after creation, and tuples cannot. They're immutable or unchangeable once you have created them. So dictionaries, they're similar to a hash table. You've got a key and a value that go in a dictionary. And keys and values are really flexible, even in a single dictionary. So for example, I have here D equals, and then a character A, and then the value is 22, and then key of an integer 5, and then a list, floating point number, and then with the value of another dictionary, and all of those are valid. And so if I were to do D5, then 1, we're going to go D and then key 5 because it's dictionary. And then the contents, the value at D5 is a list. We're going to take the 1th element, which is 3. Okay? Any questions so far? How many of you are super bored by this? Okay. Yeah.
So I've literally never used that Python before.
Yeah.
So that line makes I guess what I'm trying to ask is, should I be asking more questions to try to figure out what you're doing, or is there like a reference or resource?
Yes and yes. So first of all, whenever I have these triple greater than signs, that means I'm entering commands at in the interpreter and the corresponding output. Okay. Does that answer that help you give a little more context, or you still pretty lost?
Sure. I guess like the dictionaries, that doesn't, like, to me that almost looks like you're trying to create an array with a 2D array or 3D array.
Close. So so you're not familiar with a hash table then? Okay, so basically, a hash table is where you have this block of memory, right? And you have, there's a key that corresponds to some value, but it's not in order, right? So if you were to actually print out D right after creating it, the 3 keys that are in there might be in a completely different order because it actually uses a hash to find where that value is stored in memory. Okay, so it's really cool. If they're very useful when you want to store some information together, but you don't want to have to use like integer indexes for everything.
So the first line pretty much creates the data structure.
Yes.
And the second line tells you what index you want to find.
Yes, exactly. So we're trying to access data that is stored in this dictionary. And everything is stored in the variable D. Yeah, no problem. Please let me know if I'm skipping over details like that are leaving you confused. Okay. Yes?
So in the dictionary, key values can be a character, an integer, a floating point number. Can you do like strings, or is that just a?
Yeah, so there's no difference between characters and strings.
Okay.
A character is a string. A string is a character. Any other questions? So dictionary keys can be any hash-able data type. If you want to know what that means specifically, you'll have to look up the documentation. Okay. Slicing. Slicing is one of the coolest things that I love about Python. If you are accessing a list or a tuple, excuse me, so an array of elements, you can do regular indexing. So where here I is just some index, right? You just do regular indexing or indexing from the end. So if it starts with a negative number, that means start at the end. So you could go, this is the last element in the array. If you were to do -20, then it would go start at the end and go back 20. If you take a slice, what you do is you have the start and then the end number, or if one of them is 0, or the end, well, or you can just skip the 0 because it's implied and just go :3, and this will give you elements 0, 1, 2, 0, 1, and 2. It will stop at 3 and not give you 3. If you want the whole thing, you can just do a colon, and that's shorthand for the beginning to the end. If you want to do a slice but not take everything, you can do a skip. So both of these would start at 0, stop before you get to 6, and go every other one. So the default value for the skip space is 1, which is natural, right? Or you can do kind of crazy combos where you start at the end, you go to the 1th element, and you want to go backwards 2 every time you pull something. So, but just remember, it's start, stop, skip is the order of to access or slice lists and tuples. Okay. So this is the biggest thing that newcomers to Python struggle with, which is indentation. There are no curly braces to indicate where a function or for loop or if statement begins and ends. It's all done with indentation. So everything under this if statement needs to have the same indentation for Python to understand that it belongs to that same statement, which might sound annoying the first time you're using Python, but really it keeps your code really readable. So there's that benefit. Best practice is use 4 spaces, not tabs. Either will do, just don't mix them. The interpreter literally won't run your code if you mix them. Okay, control flow tools. So logical, if, elif, else. And by the way, this is how you do a comment in Python. You do the hash, and then everything else on that line is a comment. There is no multi-line comment in Python, no. Oh, and pass is just it just means don't do anything, because there's no curly braces to say when something starts and ends. So since this has to have something, but you don't want it to do anything, you just say pass, and then syntactically it's correct again. Yes?
The defining a variable would be like static scoping, so it's the same indentation, or does that work?
So within the same indentation, well, like if you declare something in a for loop or an if statement that's indented, it'll still be accessible outside of that.
I guess so, like when you have if A, B, would be defined above that.
Yes.
On the same line of indentation. But then if you use
Or
A
above,
or B,
yes.
Yeah, so if you use A or B somewhere else down the line, it's gonna the exact same variable value.
I think this would be easier with an example, but I don't know how to have you give me an example. Yeah. Basically, scoping, maybe it's just because I've been using Python for so many years, but it's natural. There's not, if you declare something somewhere, like in a function, it's not going to be available outside of that function. It's pretty natural scoping. There's no weird things. You have to force it to do weird stuff. So like if you have a global variable and you want to change it, you have to say, inside this function, I'm going to change the global variable. You have to tell it that you're going to do that. There's kind of that safeguard there. So. Okay. Oh, and this is print. This is how you send strings or information to the output to the screen. Loops. These are loops. So this is a really typical for loop. So what this says is I'm going to create a new variable I, which is available after the for loop is completed. And I'm going to do a range of 12. So that's shortcut for start at 0, stop at 11. So 0, 1, 2, 3, 10, 11. So yes. And then here is the F string that I was talking about. So inside of a string, it doesn't have to be double quoted. So in here I use a lot of double quotes. It's just because they're easier to see with the font that Prezi uses. So inside this string, I use the curly brace and start this pen an F at the very beginning of the string to say, I want to insert a variable where you see curly braces. So this references the variable I here. You've got to have Python 3.6 or above to do that. So we're going to start at 12, go down to 0. Decrement, this is how you do a decrement. Increment would be plus equals. That's the only way to increment and decrement. And then this will print out the message. And this comma that's after the quotes will tell print to add a space. That's something weird about the print function. Right. And then break and continue work is normal. Yes?
Is there a way to do a loop through, so in this case, you're setting it to I and then you're keeping I at the end. Is there a way to do it without declaring a variable at all? Or in a for loop?
Ooh, so kind of. No. So the technical answer is no. But if you really don't care about the variable, what you do is you just use underscore. So underscore is a valid variable name, but what it tells, and there's nothing really special per se about the underscore variable, but what it tells like IDEs is, I'm not going to use this. Don't give me a warning that I'm not using it or something.
But so I know with the underscore, the reason I ask is I think the underscore actually in Python it represents like the result of the last interactive interpreter.
Yes.
Yeah.
There's that too. You're talking about like deep stuff, man. This is an intro to Python, not deep dive with Python. But yeah. Apparently my boss wants to, yay, I have 59 minutes tomorrow. That's great. Sorry, if you don't know what 59 minutes is, that's okay.
Was it good or bad?
It means I get to get off work an hour early because of the holiday. Okay, moving on. I don't think that was right. Whoa. I'm sorry. Okay. Man. Can't like disconnect from the internet or anything either because all my stuff is online. Okay, I apologize. Functions. This is how you define a function. You define it with the def keyword and then the name of the function and the parameters. This is how you do exponents, and you don't need parentheses around everything that you return. All right, exceptions. These are exceptions. You do a try block and then an except block. If you really want to, you can do an else block. This is something that will execute only if there was no error. Here, what you can do is you can say, I'm only going to catch this kind of error, but I want to like look at that exception after I've caught it. So you can do as and then a variable name, and then within this block, you can actually access that variable. Sometimes that's really important for like operating system level exceptions. They might have like details about the file you were trying to access, but those are kind of edge cases. And then there's a bunch of other operators that you can think later. Okay. Any questions? I'm trying to go through this so that those of you that already know Python aren't too bored, but we can kind of set a baseline so that assignments are easier. So any questions up to this point? Yes.
So the assignments are going to be Python?
So same, just like the project, I'm not going to require you to use any particular language. I think so. I mean, especially if you know this stuff and reference this stuff, it's not that difficult to do, but you can do whatever you want to. Okay, let's talk about bit masking. This is not Python specific, but it will help you with assignments. Okay, so everybody know does anybody not know what bit masking is? Is anybody too scared to raise their hand? No, I'm just kidding. So everybody's familiar with bit masking. Okay, we'll go over really quickly. So bitwise OR, let's say that you want to, this is bit masking. You say I have one number and another number, I want to bitwise OR them. Any ones in the sequence in either one of them translate to the result. So what we can do is we can use this to combine two things to get all the ORs. The next one is AND. This, of course, just like other AND operators, is only true or one if both bits in that position are 1. So you can see here this ends up being 0. The other ones are 1. Okay. Yes?
So what's the bit mask?
So we're saying we want this number and we want to figure out.
I understand the operation.
Yes. So what this is doing is this number is the bit mask. Okay. And what this series of ones is telling you is I want to keep all the numbers in these locations, but not the last one. That's really what it's telling you. Okay, and so, okay, all right. So we can extract the values of bits at certain positions by placing ones at the bit mask. So if we just wanted these 4 bits right here, then everything else would be set to 0 on either side of those values. Okay, questions? This makes sense? Okay. Last one is exclusive OR. So same principle. but XOR, right? So you can see here we've got all ones, so we're just, you know XOR, hopefully. Maybe, no, whatever, I'm moving on. Okay, so the second value is known as the bit mask. Okay, let's keep moving. This is taking longer than I thought it would, but that's okay. I'm glad that we had lots of questions for the project description. It means my lecture slides will last longer. Okay, let's take things to the next level. Files, this is how you operate on files. You gotta open the file, just like anything else. But you have to also tell Python what mode you want it in. So these are the different modes: read, write, append. If you're working with binary files, you just add a B. This is another way of doing it. So this with keyword tells Python, hey, I'm going to create a context. So within this context, I want you to open the file and the result and save it as this variable fin. And then internally, what Python does is once it exits the context, it closes the file. So that's specific to the open function. The open function has been written with this context manager in mind so that it will do that operation when it exits the context. Good? Okay. All right. If you need to close it, meaning you didn't use a with block, this is how you close it. If you want to iterate over the lines of a text file, you can just say, my file is fin. I'm going to look at each line in the file and do something with it. If you need to jump around in a binary file, very similar to other languages where you can tell or figure out what position in the file you're currently pointing at, go to a specific byte, go to the third byte before the end, meaning that this number 2 tells you from the end. If you were to do 1, you're going to seek either forward or backward from your current position, and then read in 2 bytes. And again, this is for binary files. Questions? Okay. Okay. For all of your homework assignments, I have a lot of command line parameters, right? Who likes having to parse command line parameters in your programs? Are you using Python? Okay, so yeah, that's the only reason why you would like it is if you're using Python. It's painful. It is painful stuff, right? But Python makes it easier for you. I don't know if any of you have used or heard of the web micro framework Flask. Very popular. The same people that brought you Flask also brought you a library called Click, which is excellent for writing command line programs because it makes processing command line parameters much, much easier. So that's all I'm going to say about this. You can read it later if you want to. The link is already on the website. Okay, now that we've gone through some beginner and intermediate functions in Python, this is how you work with bits. Hopefully this is new to at least some of you because it's a little bit more advanced topic in Python. So let's say you have X and Y variables, that X has a value that you want to shift by Y number of bits. You can shift right this way and shift left by doing this. The bitwise, like bit masking operations that we were talking about a minute ago, this is how you do that. And, or, exclusive or. Now, yeah. Yep. So this int and then a string and then 2 tells Python, I want this string, I want you to convert it to an integer, and it happens to be in base 2. So give me that integer. Okay, moving on. So this example opens a binary file holding a single number. The binary file holds just one number. In little endian, oh, we haven't talked about little endian yet. Who knows what little endian is? Okay, that's gonna make your life easier if you already know what little endian is. Oh man, sorry, I forgot that was in here. We're gonna get to that Not anytime soon, I'm sorry. Okay. All right, reads 1 byte at a time, converts it to decimal, and prints it to the screen. So the one thing that you need to know about little endian is that when we write numbers out, we have the most significant numbers on the left, right? We write it out like that. Well, if you were to just put that in memory, it would also look like it was left to right. But the thing is that certain processors, they don't like to process numbers from most significant bits to least significant bits. Hopefully I'm not misspeaking. I feel like I've said something wrong. Okay. They want to know the least significant byte, the least significant byte first. So it's like if you had two bytes in memory that represented a little endian number, the first one would be the least significant bits of the number. So to make it human readable, you would have to swap those 2 bytes before you hand converted it to decimal. Whose brain just exploded? Okay, don't worry about it. We'll go over it more later. Okay. All right, so we're going to open the file in this with block. We're reading it as a binary file. We're going to keep track of the bits here. And this is an infinite loop that we exit down here when there's a break statement. So we're going to read 1 byte, store it in B. If we don't get anything, that means we've reached the end of the file, so we're going to break out of this while loop. Otherwise, we're going to get N, which is kind of storing everything that we're collecting, and bitwise OR it with B, which is currently a bytes type data type. It's bytes data type, and it's in big endian. We're telling it it's in big endian right now. We're going to convert it to an integer and then shift everything left by the number of bits that we've read in so far. So we read in 8 bits, and so the next time we're going to shift it by more 8 bits. How confusing is that, right? Basically, this converts from little endian to big endian integer. And here's a cool exercise. If you can figure out how to do this in only 2 lines of code, then you've actually started to understand Python. Okay, so there's a little challenge for you. Who's confused? Which part confuses you? Do you want to come up to the board and point?
I guess I'm trying to relate this, how I can like actually use it in Python. I just downloaded Python and it looks like a terminal window.
Yeah.
So I think I'm just having to play with it. Like, go on.
Okay. Yeah, if you create a binary file, oh, oh sorry. Okay, I guess I was ill prepared for this lecture. I apologize. So I'm again, I'm not going to require you to know Python or use Python in your assignments. So hopefully that makes things a little easier on you. But I would like it if each of you at least gave Python a chance, because I think it will make your lives easier. And historically, that's been the case. Right? So forensic students have had this lecture several times. And every time there's several students in the class that say, well, because of that, I decided to use Python, and it ended up being not that big of a deal, and I was able to do it. So, yeah.
The biggest problem is, like, I remember when I first started Python, same problem, but Python has so many things built in. It's not like C++ where you're trying to figure out, okay, why is it so little to seemingly do so much?
Right.
So there's a lot of semantics that you actually have to learn first, but then once you do, all of it pretty much reads like English at that point.
Like for example, there's nowhere you don't have to declare the data type for any variable, so it's not obvious where it's not initially obvious where a variable is initialized, right? Because you're just seeing that it's getting set to a value. There's not like an int n equals 0, right? So that's an yeah. Play around with it, and if you still have questions, please let me know. I'm always happy to talk to people about Python, like all day. I'll talk to them about it. Yes.
I don't know if I just missed it in the slides or you cover how to instantiate, like creating your own object classes and stuff like that.
No. I figured you're not going to need to, for any of the programming assignments, I don't think you're going to need to create a class object. So that's why it's not covered. Yes.
Do you want us to actually answer the question?
No, not right now. Like this at home, if you're like, man, I'm going to see if I can do that in 2 lines of code, go for it.
Okay, I just had a kid.
No. Oh, yeah. Okay. Well.
I won't say it.
Okay. There's a couple more things I want to cover in this lecture before I let you go. So let's get to that. So dealing with data types. So if you want to check the type of a particular variable, you would call the type function on that variable. So this is just could be any variable. Another way to do it is to check, what is it called? The isInstance function, where you give it x is the variable name, and then string is the data type. So it's a keyword, predefined data type, and so this will evaluate to true if x is a string. And also that goes for any inheritance. So let's say I were to create my own data type that inherited from string. If I were to call isInstance x, so if x was an instance of my own data type that inherited from string and called this function, it would still evaluate to true. Because my subclass is a string as well. All right, encoding and decoding. This is kind of important to your homework assignments. Strings and bytes can be encoded and decoded to different types. So again, this is all these mean that we're working in the interpreter. I got to import this library codex. And then what I can do is I can give the codex library a binary string, a byte string, and tell it to encode it into hexadecimal. And it will spit out this bytes string, which is pretty nice. I can also decode from hex to the UTF-8 equivalent. Okay. Binary, let's say we have a string that we want to convert to binary, get its binary value. We can do this. We can also do, so this was the precursor to F strings, where you had to have the string and then do dot format. So this tells the string that the 0 said I need to get the 0th element or parameter to the format function, and the B tells it to convert it to binary. So the 13 is an integer and is being converted into binary and put into a string. Okay, that's what this does. Okay, and then there's lots more things that you can do with the codex library. Okay, data extraction. Everything's been leading up to this one slide, okay? So if you can get this through this slide, then we're done, and you can never look at Python again if you don't want to. Okay, so a struct. It is possible to create structs in Python, and this is how you do it. It's a great way to pack and unpack binary data. Does that sound familiar? Have a binary data structure that you have to unpack, and your group project that I introduced earlier, right? You have, there's a binary structure, right? Okay. All right, so we're going to use the struct library by importing it, and then we're going to create a variable called myStruct that has this structure. So what this string here says is there's going to be 2 4-byte integers, that's the 2 i's, and then a 10-character string. All of the documentation for what all the strings mean and what you can use is all here at this link. Okay. And then when I have binary data that I want to unpack into its various parts, I would call the myStruct.unpack method on that byte data, and it would be stored in this variable. Okay. So let's do an example. Let's say we've got this binary data here, and it has this format where there's a 4-byte index, a 25-byte address, 3-byte zip code, et cetera, et cetera, et cetera. And this is the actual data. We don't want just binary data. We want to be able to actually say, all right, for the first record in this file, I want to know the zip code. The only way the only way you can do that is by unpacking it from binary data into its various components of these records. So this is how you do that. I'm actually giving you workable Python code that I wrote several years ago, by the way, but still it will still work. So we're going to import struct. We're going to create a new structure where this string corresponds to this format up here. Okay, so we've got an integer, and then a 25-byte string, and then a 3-byte zip code. Yeah, and then 21-byte name, 10-byte phone number, a string, and then a new line. So that's not part of this. And you'll see why in a second. So we're going to open the file, the binary. We're going to iterate through every line in the file in this block here. So we want one entry, and then to be able to pull out all the constituent parts. So we're going to call the structure that I created up here, unpack it on one of the lines. Now here you'll see that every line is delimited by a new line character, right? So we're removing the white space by calling the by calling the strip method on this line that we read in from the file. Okay, so a reason up to and including the new line character, but we want to take the new line character off so that we have the exact structure to unpack. So unpack it. This is now, I believe it's a list. It might be a tuple. I'm not sure. It's one of those. Probably a tuple, if I had to guess. So entry 0 is the first thing in this data field, right? So the index, we have the index address at 1, but because it's currently in bytes form, we have to decode it into UTF and then strip off any white space from the beginning and end. We're going to convert this one to an integer. We're going to convert this to UTF-8, and then we're going to print all of it with this format string that indicates, so the 0 corresponds to the index, and then we're doing some formatting there so they all line up. I don't know if you guys have used format strings before, but hopefully you have. And then the third one, so 0, 1, 2, 3, this is name, is next. And then we're going to do a bunch of white space on the next line, get the address, and then the zip code after we do a comma, and then number 4, the phone number on the next line. Okay, did walking through that help? Okay. Again, so this is a code example that works. If you had this file, it would pump out records from that binary data.
The output is top right.
This is the input. This is the input to this function. It just happens to be viewed in a hex editor.
So it's like less than 10 lines of code. That doesn't input all of that information, or does it?
So this This will iterate over however long this file is. And for each record, because it has a binary structure, it will print out each record in this format. Huh? Okay. Our time's up, but, oh, little Indian. Yeah, okay. All right. Good luck. Look over the project description. Let me know if you have any questions. Please ask them on Piazza, because likely if you have a question about the project, someone else does, okay? All right, have a great long weekend. We'll see you on Tuesday. Hold on one second.